Gas chromatography mass spectrometry, or GCMS, is an analytical technique used to analyze samples in a solid, liquid, or gas state, utilizing two chemical processes called gas chromatography and mass spectrometry. First, before discussing the principles of the GCMS, let's talk about their inventors. The two men on the left are Anthony T. James and Archer J.P. Martin, the creators of gas chromatography, and the man on the right is J.J. Thomson, the creator of mass spectrometry. This is the first process in gas chromatography mass spectrometry. This is gas chromatography. Gas chromatography is a process that relies heavily on the different affinities of vapor compounds or surfaces. The principles of it are that the mixture is dissolved in a solvent. The compounds are separated approximately by boiling point. The lower the boiling point, the faster the movement, but a lower retention time. Then the sample is vaporized and injected into a heated separation tube commonly known as the column, which contains an inert gas from the canister. Due to the mixture containing a variety of elements, they have different affinities for the solid surfaces, resulting in the separation of the mixture within the column. There are two phases in gas chromatography, the mobile phase and the stationary phase. During the mobile phase, the inert gas will be used to carry the molecules of separated mixture through the column. The stationary phase works when the column is acting as a solid support or is coated with a high boiling polymer, which acts as a liquid stationary phase. As the separated mixture reaches the end of the column, there will be a specialized detector, which produces a signal as each compound reaches the end of the column. This signal, as well as its intensity, will determine the corresponding relative abundance of that chemical in the given mixture. These results can then be placed on a chromatogram, which will show the peaks of each mixture in the given substance. The second process I'm going to be discussing is mass spectrometry. The process works by first bombarding the substance with electrons to knock off one of the electrons in the substance's outer shell, making a positive ion. This process is called ionization. These ions can then be accelerated by introducing a negative electrical field due to the positive ion being attracted to the negative electron field like magnets are to metal. Once the ions have been accelerated through an electric field, their trajectory will alter depending on their mass, meaning the ion stream will become bent and separated. Once this sample has undergone ion drift, the process I just talked about, these ions will strike a negatively charged photographic detection plate, and depending on their mass to charge ratio depends on the time they'll hit this detector. Once they make contact with this detector, this will create a current, which can be analysed to determine the identity of the element. These are the two men that join these two processes. They're called McLafferty and Gokul. This machine here is the GCMS, and as you can see by the labels, there are many different parts of this machine. Each component of this machine has a very different reason of being there. First, we're going to look at the carrier gas canister, which normally contains a gas like argon, helium, or hydrogen, normally an inert gas. I'm going to start with the GCMS is the autosampler, which is responsible for storing each of the individual chemicals. They also reproducibly deliver the sample to an analytical instrument in which the sample is going to get analysed. In this case, it's the GCMS. The next component I'm going to discuss is the auto-injector. As you can see from the picture on the left, that is an auto-injector. Its main purpose, as the name suggests, is to inject the sample into the GCMS via the port you can see in the middle. The picture on the right is the column that I discussed earlier. Within it is the column oven used to heat it up and conduct gas chromatography. Once GCMS has been completed, the abundance and time is plotted on a chromatogram, which can then be used to discover the elements themselves as well as their abundance within that sample. The GCMS can be used in various fields, such as medicine for testing for congenital diseases. They can be used in the environment to test for any sort of pollutants. The GCMS can also be used for the analysis of all types of oils and perfumes. They can be used in pharmacy to detect impurities in active pharmaceutical ingredients. It can also be applied in medicinal chemistry in synthesis. Finally, it can also be used in forensics in many different areas, such as arson and toxicology.